Every spring since 2001, MIT Technology Review has published a list of the 10 breakthrough technologies that we believe will have the biggest breakthroughs of the year. Innovations that are a clear advance in their field. This list helps our readers understand which technologies are likely to have the biggest impact on businesses and society. To create it, we solicit guidance and solicit guidance from experts around the world, from companies, investment firms, and from research labs. So a reasonable question is how have we fared? How have our predictions fared to date? Well, over the years, we've identified many technologies that have gone on and flourished to become part of our everyday lives. But sometimes we've gotten it very wrong, or sometimes we've just been too early. In 2001, we wrote about Stephen Quake's work in microfluidics, driven by the technologies used in gene sequencing machines and for diagnostic devices. The market for microfluidics is estimated to be by around $4 billion by 2020, according to Lux Research. But in 2009, we found a smart personal assistant inside SRI, the Silicon Valley research giant, which astonished us by its naturalness. And that became Siri when Steve Jobs purchased it for Apple's iPhone. And today, smart assistants are ubiquitous on our devices and have made leaps into our home, like Amazon Echo, Google Home, and others. But here's something that we got wrong, horribly wrong. Social TV was a 2010 breakthrough technology that we talked about. And we thought that somehow social media and broadcast would perhaps merge, but they don't. They remain obstinately separate streams that people experience simultaneously, tweeting their impressions of presidential debates, while they watch them on TV. But let's take a look at this year's list. 3D metal printing is our first breakthrough. This video is from Desktop Metal, a metal 3D printing company in Massachusetts that is at the cutting edge of making 3D printing quick and affordable for the masses. This particular printer is the Desktop Metal production system and can print 100 times faster than any other metal printer. And at a $120,000 price point for the entry-level printer, they are not currently at a price point which is available to everybody to have in their homes yet. But the entry-level printer is, however, at a price point that small businesses or universities can afford, so it makes product prototyping even quicker and possible for future generations. And this could really transform manufacturing. GE has long since been a proponent using 3D printing in its aviation products and has a test version of its new metal printer that is fast enough to make large parts. And the company begins to start selling them this year already. Our key players are Desktop Metal and GE and Markforged. Artificial embryos is our next breakthrough. In a breakthrough that redefines how life can be created, embryologists working at the University of Cambridge in the UK have grown realistic-looking mouse embryos using only stem cells. No egg, no sperm, just cells plucked from another embryo. And then researchers really watched fascinated as they started communicating and lining up with one another to self-organize so distinctively in the shape of a mouse embryo that was, a few days old. And these synthetic embryos probably couldn't have grown into mice, but nonetheless, they're a hint that soon we could have mammals born without an egg at all. And it matters because artificial embryos make it easier to study the mysterious beginnings of human life. But this all poses, of course, a lot of ethical questions, such as what if they turn out to be indistinguishable from the real embryos, and how long before they start feeling pain? And we need to address all of these questions first, obviously, before we race ahead with the creation of human embryos. Our key players here, University of Michigan, Cambridge, and the Rockefeller University, and its availability is now. Sensing City, Alphabet Sidewalk Labs, plans to create a high-tech district to rethink how we build and run cities. A Toronto neighborhood aims to be the first place to successfully integrate cutting-edge urban design with state-of-the-art digital technology. Numerous smart city schemes have failed, but this new project in Toronto is called Quayside. Alphabet Sidewalk Labs is based in New York City and is collaborating with the Canadian government on this high-tech project slated for Toronto's industrial waterfront. One of the project's goals is to base decisions about design, policy, and technology information from an extensive network of sensors that gather data on everything from air quality to noise levels to people's activities. The plan calls for all vehicles to be automated. Robots will roam underground, doing menial chores like delivering mail. And Sidewalk Labs says it will open access to the software and systems that it's creating so that other companies can build services on top of it, much as people build apps for mobile phones. And other North American companies are now clamoring to be next on the list, such as San Francisco, Denver, LA, and Boston have all asked for introductions. Our key players. The project was announced last year in October, and because construction could begin next year already. Our next breakthrough, AI for everybody. Making machine learning tools available through cloud services could spread artificial intelligence far and wide. And AI so far has mainly been the plaything of big technology companies like Amazon and Baidu, and perhaps some very well-funded startups. But for many other companies, AI systems are too expensive and difficult to implement fully. So what's the solution? Well, machine learning tools based in the cloud are bringing AI to a far broader audience. So far, Amazon dominates cloud AI with its AWS subsidiary. Google is challenging that with TensorFlow, an open source AI library that can be used to build other machine learning software. And then recently, Google announced Cloud Auto ML, which is a suite of pre-trained systems that could make AI simpler to use. But there are more, and it's unclear which of these companies will dominate in the future, but it is obviously a huge business opportunity for the winners. Most companies, though, still don't have enough people that know how to use cloud AI, so Amazon and Google are also setting consultancy services. So once the cloud puts the technology within reach, almost everyone, the real AI revolution will probably be able to begin. Our key players here, very clear. Breakthrough technology number 5, dueling neural networks. 2 AI systems that can spar with each other to create ultra-realistic original images or sounds, something machines have never been able to do before. For the last decade, we've featured advances in artificial intelligence in each of our 10 breakthrough technology list. Last year, we highlighted self-driving trucks and reinforcement learning. This year, we're surfacing dual neural networks, otherwise known as generative adversarial network, or GAN. A GAN is 2 AI systems that are pitted against one another, with the first AI system trying to create something brand new, and then the second system trying to determine if it's fake or not. So researchers at NVIDIA trained a GAN to generate pictures of imaginary celebrities by studying real ones. So not all the fake stars it produced were perfect, but some were impressively realistic. So this gives machines akin to a sense of imagination, which may help them become less reliant on humans. And in a world where information on the internet is unreliable and we are concerned with the effects of fake news. Will these advances in artificial intelligence become a tool for people who want to spread false information? Perhaps. Our key players, Google, DeepMind, NVIDIA, and it is already available. Like the Babel fish from the cult sci-fi classic, The Hitchhiker's Guide to the Galaxy, which sits inside your ear and instantly translates languages, new technologies developed by Google and Baidu promises a world where technology can break down language barriers. Near real-time translation now works for a large number of languages, and it's really easy to use. So one person wears the earbuds while the other one holds the phone. The earbud wearer then speaks in his or her language, English is the default, and the app translates the talking and plays it aloud on the phone. The person holding the phone responds. This response is translated and played through the earbuds. In an increasingly global world where language is still a barrier to communication, we thought that this was a very big breakthrough. Our key players here, Google and Baidu. Zero carbon natural gas. This is a pilot power plant just outside of Houston, which will more efficiently and cleanly capture and reuse the carbon released by burning natural gas. The world is probably stuck with natural gas as one of our primary resources of electricity for the foreseeable future. Cheap and readily available, it now accounts for 30% of US electricity and 22% of world electricity. And although it is cleaner than coal, it is still a massive source of carbon emissions. The company Net Power believes it can generate power at least as cheaply as standard natural gas plants and capture essentially all of the carbon dioxide released in the process. And if so, it would mean the world has a way to produce carbon-free energy from a fossil fuel at a reasonable cost. Such natural gas plants could be cranked up and down on demand, which then avoids the high capital cost of nuclear power and sidesteps unnecessary unsteady supply that renewables generally provide. So Net Power's technology won't solve all our problems with natural gas, particularly on the extraction side. But as long as we're using natural gas, we might as well be using it as cleanly as possible. And of all of the clean energy technologies in the development, Net Power's is one of the furthest along to promise more than just a marginal advance in cutting carbon emissions. Our key players here, 8 Rivers Capital, Exelon, Generation, CB, and I, and our availability here 3 to 5 years. Perfect online privacy, a tool developed for blockchains, makes it possible to carry out a digital transaction without revealing any more information than is absolutely necessary. True internet privacy could finally become possible thanks to a tool that can, for instance, let you prove that you're over 18 without actually giving your age away, or prove that you have enough money in the bank without revealing your salary. So this limits the risk of privacy threats or identity theft. The tool is an emerging cryptographic protocol called a zero-knowledge proof. Though researchers have worked on it for decades, interest has exploded in the past year, thanks in part to the growing obsession with cryptocurrencies, most of which aren't private. So for all of their promise, though, these methods are computation-heavy and slow and require a so-called trusted setup, creating a cryptographic key that could compromise the whole system if it fell into the wrong hands. But researchers are looking at alternatives that deploy zero-knowledge proofs more efficiently and don't require such a key. Our key players here, JP Morgan, ING, Zcash. Genetic fortune telling is our 9th breakthrough. Large genetic studies are allowing scientists to predict common diseases and human traits. Scientists can now use your genome to predict your chances of getting heart disease, breast cancer, even your IQ. So this photograph is from the UK Biobank showing the 500,000 frozen DNA samples that were donated by British volunteers as a part of the UK Biobank's effort. A robot is on the yellow rails searching amongst the samples. DNA predictions could be the next great public health advance, but they could increase the risk of genetic discrimination. Our key players here, Helix, 23andMe, Myriad Biobank, the Broad Institute, which is right next to MIT campus, and the availability is now. Our final breakthrough is materials quantum leap. Researchers recently used a quantum computer to model a simple molecule, and that is just the start. IBM has simulated the electronic structure of a small molecule using a 7-qubit quantum computer. The prospect of powerful new quantum computers comes with a puzzle. They'll be capable of feats of computation inconceivable with today's machines, but we haven't yet figured out what we might be able to do with these powers. One likely and enticing possibility is precisely designing molecules. And chemists are already dreaming of new proteins for far more effective drugs, novel electrolytes for better batteries, compounds that could turn sunlight into a liquid fuel, and much more efficient solar cells. In this image, the chips inside at the bottom of this quantum computer from IBM are cooled to a 15 millikelvin. That is, to explain how cold that is 15 thousandths of a Kelvin from zero, where 0 Kelvin is absolute zero. And absolute zero is where all matter freezes. Everything comes to a stop. I believe that's approximately minus 273 degrees Celsius, but you can question me on that at the coffee break. And this matters because understanding molecules in exact details will allow chemists to design more effective drugs and better materials for generating and distributing energy. Our key players here are Harvard, Google, and IBM. So why does any of this matter, really? But it matters because technology can do a great many things for humankind. But as a society, we do need to talk about how these technologies should be used and can be used, and not how we are going to be used by them. So thank you. Please visit us at technologyreview.com.